Today we're going to be studying the graphs of functions. We will be able to determine the domain and range using graphs and describe graphs using interval notation. First, we need to remember that the domain is all the possible x values in a function, and the range would be all the possible y values. One very, very, very important thing that we need to pay attention to is how we describe the graph. In pre-calculus, we describe graphs using interval notation. Interval notation is a way of describing a specific portion of the graph. Typically, we will use the x values when we are using interval notation. The only situation when we would not use x values is if we are describing the range, in which case we would talk about the y's. This notation looks like it's a point, but in fact, it is telling you a range of numbers. I don't necessarily know what this interval from 3 to 10 is talking about, but I do know a few things. 3 would be the starting point. And 10 would be where I stop. Again, we don't care what the y values are. We're assuming that we could look at the function and determine what the y values are. We only care about the x values. We also need to pay attention to the brackets. A round bracket means not inclusive. It's almost like saying greater than or less than, or an open dot instead of a closed dot. A square bracket is inclusive. So that could be described as a closed dot, or it could be thought of as greater than or equal to or less than or equal to, depending on where in the graph and in the notation your square and round brackets are. So let's try this. Whenever we want to talk about all real numbers, we describe it like this. We say that our interval is from negative infinity to positive infinity. That's something to keep in mind because we'll use that a lot later. So here I have a function, and I have a function notation. I want to know the y value where the function is, where the x value is -5. So I go to -5, and it looks like my y value is a little bit less than 1. So I'll say 1.9. The function value is 0. So if x is 0, y is 7. The function value at 2. So if I look here, I actually almost have 2 options. Since this is a closed circle, or an open circle, I don't have a value there. This is also an open circle, so I don't have a value there. So there is no solution at the value x equals 2. And then f of 10 also has no solution because the graph stops at x equals 7. So there is no solution there as well. Now let's focus on the domain and range. The domain is all possible x values. So my x values start here at -6, -7, -8, and continue to +7. The smallest number should always go first. So the smallest number this time is -8. I'm going to use a square bracket because I have a closed dot here. And I know that my biggest x value is 7, but pay attention here, where we were looking at x equals 2. There is no value there. So I have to account for that. I do that by saying that the range goes from -8 to 2 with a round bracket, because I don't want to include 2 in my answer, and then starts at 2 again and continues to 7 inclusive. Let's look at the range. Now, range is the only time we're going to look at the y values. So I want to start with my smallest y value, which is -9, and it's included. So I know I'm going to start there. I'm going to continue up, following my function. I'm looking for holes in my graph. I want to see if there are any places where I don't have a y value. And if I follow along, it looks like every y value is covered all the way till I get to 8, right here. So the range was simple. -9 to 8 inclusive. And again, I looked at the y values because I'm talking about the range. We can also describe graphs with intervals in other ways. Common ways are to describe where the graph is increasing and decreasing. Sometimes it helps to use different colors to help you figure out increasing and decreasing. Again, this is a situation where I want to focus on the x values. I don't want to focus on the y's. Whenever you read a graph, you want to read it left to right. So starting here, if I'm going from left to right, the graph is going down, even though this arrow is technically going up. So I'm going to mark that in blue because the graph is going down. And then it turns around and starts to go back up. And then it turns around again and goes back down. And then finishes going up. Sometimes it's easier to find the intervals of increasing first and then do the decreasing. Now, at this point right here, here, and here, these are maximums and minimums, which we'll cover in a second, but the graph really isn't increasing or decreasing at that point. It's changing direction. So my first interval of increasing starts at x equals, we'll say 1.5, -1.5, and stops at 0, or stops increasing at 0. I'm going to put round brackets here because at 1.5 itself, it is not increasing or decreasing. Same thing with 0. And then at 0.5, it goes up and then goes to infinity. So this graph is increasing on the interval -1.5 to 0, and then from 0.5 all the way to infinity. Decreasing works the same way. My lowest decreasing point is infinitely small. So I'm going to say that it goes from -infinity and stops decreasing at -1.5. And then I have this small section here from 0 to 0.5 where it's also decreasing. And again, round brackets because none of these numbers are technically included. So that would be my interval of decreasing. Now, when we're talking about maximums and minimums, we could use the point itself, but again, we really only care about the x value. So my maximum occurs right here at 0, and I have two minimums, -0.5 and 0.5. These infinities, here and here, really can't be maximums or minimums. It's only where you see the change in direction. And we will stop here for today. Please write down any questions that you have, and we will cover them in class.